Okay, goal 6.3 involves dividing a polynomial by a polynomial using long division. It would be my guess that a lot of you have not done this before, and it's a little bit of a challenge, but it's very methodic. You do the same thing over and over and over. Okay, so I think that you'll catch on to it. It is really important that you are neat and you keep things in columns, because that's important in long division, just like it was when you did long division with numbers. Okay, so it's really important that you're keeping things lined up. Okay, so when we set this up, what I want you to notice is that we have an x squared here. That's called a quadratic term. An x term, that's called a linear term, and a constant term. So we go in what we call perfect descending order. X to the second, x to the first, no x's. That's important. The order, I'm not going to make it out of order, but at sometimes there's going to be things missing. When I get to that, I'll show you. But that's important to look at that before we start the question. Okay? So it all looks good on this one. So when we set up our division, it literally looks like a long division question. X squared plus 4x plus 12 divided by x plus 3. So you start, when you do your division, you use this x term to do the division. You don't use the 3 to do the division. Just use this first term, whatever it is. And you start by taking x divided into x squared. I personally think multiplying is easier than dividing, so I word it differently in my head. So that's what I'm going to do for you, because I think you'll have an easier time with it. So, in other words, what would I multiply x by to make it x squared? X. And that goes up here. Now, think back to long division with numbers. What did you do when you put a number up here then? What was your next step in long division? Anna?
You multiply by the
divisor.
divisor.
Okay, you multiplied it by that thing out here. You could use not mathematical terms there. That's exactly what you do here. So we're going to take x times this quantity. Okay, so x times x is x squared. And then x times a positive 3 is positive 3x. What did you do at this point in long division? You subtracted. Now, this one's not so bad, but there are times when our subtraction is a little tricky because we're subtracting with negatives, and people don't typically do that very well. Okay? So, subtracting is the same as changing the signs and adding. Okay, you've done that way back when you first learned to subtract. So for example, if I took 7 minus 5, what you learn to do is change this to a minus and this to a plus. Changing the signs and adding. Okay, that's what subtraction is. So, on this one, I think it's simpler because of negatives to do exactly that. Change the signs and then add. So positive x squared and negative x squared cancel out. That first thing should cancel out every single time. If it doesn't cancel, you've done something wrong. Okay, they should match each other. When you change that sign, they should be opposites, and then they cancel. And a positive 4 and a minus 3 gives me a positive 1x. And what did you do in long division next? Rephrase that a little bit. You bring down the next number. So you do the same thing here. You bring down positive 12. Anna, what was your question here?
Do you really have to change all those things?
No.
Or just
You can just subtract. Just be careful. If this were a minus 3, then you just got to make sure you know how to do 4 minus a negative 3. Yeah. Okay, so now we repeat the process. We're going to take x divided into x. Or what do I multiply x by to get 1x? X times what is 1x? 1. What kind is 1? Positive or negative? That's important. You've got to have a sign. So plus 1. And then we multiply the 1 times everything out here. So 1 times x is 1x. 1 times 3 is positive 3. And then we subtract. So if you just can subtract without changing the signs, go ahead and do that. Be careful in negatives though. So I'm going to change my signs and add. And the first one cancels. They should cancel every single time. And 12 and minus 3 give me a positive 9. That is my remainder. But we're not going to write it R9 because we're in Algebra 1 now. You're not finished. You got a couple more usually. Come on. We're not going to write it R9 like we did when we first used long division. We're going to write what it mathematically means. What do I really have left? So let's go back to something that you've done a long time ago. If I take 13 divided by 4, and I get that remainder of a 1, what does that mean I'm really left with? 1 over 4. Very good. It means you have 1 over whatever this divisor is left. It means you have a 4th left over. So polynomials work the same way. It means I have left 9 over that x plus 3. And then we always add our remainder. So it's whatever we get for our remainder, it's going to be plus our remainder, 9, over our divisor, x plus 3. It's a little weird. You've never done it before. It's kind of strange. It's very different. And it actually, even when you watch me do it until you sit down and try it yourself, you got to do it. Yes?
So would that be the final answer?
That's your final answer.
Wait, so how did you get the x plus 3?
How did I get the x plus 3? I took this 1. When I put that 1 up there, so I took 1 times x and 1 times 3. So you're going to repeat my process. When you put that number or that variable or whatever you put on top and multiply it through, in this case the 1, so the 1 times the x plus 3. Okay, give it a couple questions to sink in. Let's look at the next one. Again, you'll notice x to the second, x to the 1, no x's. That's important. So it's ready to go. So I'll set it up. And I divide. I'm going to take 12x divided into 48x squared. Or you can reword that in your head. What would I multiply 12x by to get 48x squared? Grant? 4x. 4x. Now just like in long division with numbers, I'm going to take what I put up here times what's out here. So in this case, it does mean distributive property. So 4x times 12x, 48x squared. Those should match. If they don't, you picked the wrong thing up there. 4x times negative 1, negative 4x. Here I subtract. Again, you don't have to show me change the signs and add, but this is one of those ones that if you don't know that 8 minus a negative 4 is going to give me 12 here, then be super careful. I'm going to change the signs and add. I think it's simpler. Even if you change the signs mentally and not write it. So the first ones cancel, they should always cancel. 8 plus 4, 12x. And just like in any long division question, we bring down the next term. And we repeat exactly what we just did. Did I get a 1 on the last one too? I did. They don't always come up like that. So I'm going to take 12x, divide it into 12x, or what do I multiply 12x by to get 12x? Positive 1. That happened on the last question that it was a 1. That's not always going to happen. Should have made a better problem. So I multiply through. 1 times 12x is 12x. 1 times minus 1 is minus 1. Here I subtract. Subtraction, same thing as changing the signs and adding. So the first one cancels, as it always should. 7 plus 1 is 8, which is my remainder. And I write as plus, it's important to have the sign there, 8 over 12x minus 1. Anna?
So the numbers on the add side of the division box, that would go as that would go like underneath the fraction.
Correct. Correct. Jordan?
I don't get why you changed the signs on 4x and...
You don't have to change the signs. You just have to be able to subtract really well then. Because right here in long division, you're subtracting. So let's just not change the signs. I'll just erase them and show you. As long as you can subtract well, you don't have to write that. So 48 minus 48 would cancel. And then you have to know that 8 minus a negative 4 would make that a positive 4 and give me 12. So you have to know that you're subtracting. And if you can subtract negatives well, I think it's easier because subtraction just means change the signs and add. So that's why I changed the signs and just add them. Yes?
Do you always change the signs?
Yes.
We don't have to.
You can just think of it as subtraction, yes.
Why is it a negative 4 and why are you making it?
Why is it a negative 4 to begin with?
Yeah.
Okay, up here I have my 4x. Once I decide what this is, I'm going to take 4x times 12x and get 48x squared. And then 4x times negative 1 is where the negative 4x in blue came from. Then when I go to subtract, which again, you don't have to change your signs, but if you do not subtract well with negatives, then change them. So I changed my subtraction to change the signs and add, which is the same thing that subtraction is.
What if your top number had a negative and your bottom was positive?
Here,
No,
my
like,
remainder.
Say the 12x plus 7 was like 12x
I'm going to get to that
minus
right now. Your next question. Yes?
How did you get the plus 1 after 4x?
Before I did this, I took 12x divided into 12x, which is my 1.